Okay, so we can get started. Good morning to everyone for joining this 12th session on the introduction to data science. We do have a few people from outside who are joining for the first time. The objective here is to introduce data science, not to go too deep into technical stuff, but to introduce data science and its applications, right? So we do have Dr. Thushan Ganegedara, senior machine learning engineer at Canva, Australia. It's one of the leading companies at the moment in Australia and throughout the world. And he's a graduate from the Department of Computer Science and Engineering. And then after that, he got his PhD from University of Sydney. And now he's a senior machine learning engineer at Canva. And not only that, he's an educator. And also he is the author of a few books. One is, I think, on TensorFlow. And he's actively engaged in promoting machine learning and presenting machine learning in interesting ways to make it interesting. So let me take this opportunity to thank him for joining us at this time, and also being willing to share his knowledge with our students and the wider community in Sri Lanka to promote data science and related fields. Yeah, over to you, Thushan. You can continue your session.
Yep, great. Thanks, sir, for the introduction. So, hey, everyone. Can you guys see me, by the way? Just kind of like to show my face when I'm speaking. Can you guys see me?
Yeah, we can see you.
Oh, okay, great. All right, so I'm Thushan Ganegedara, and I've titled this presentation as A Different Introduction to Data Science. So why did I decide to make this different? Because different things usually stick with you better. Because it's kind of like when you're like mom is screaming at you every 10 seconds, you kind of tend to ignore that as background noise. And then once you get a slap or kind of, hit on your head, just realize you've done something wrong and you've made her mad. That's, how you kind of get that signal. So the same goes here. Whenever something is different, just kind of sticks with you a bit stronger. So the other question is, how is this different? There's a few differences. There's this misconception in data science that, being able to deliver good technical solutions would make you a good data scientist, which is not the case. So you're going to see that kind of firsthand how it is different. The second thing is there are other misconceptions that you will always be developing like great machine learning models, kind of designed to take over the world, do amazing things, which is always not the case. So I'm also going to burst that bubble. So that's how this is different. Let's see how this goes. Cool. So let's get started. All right, so let's establish some ground rules. So it's up to you to make this a valuable session. By up to you, I mean the students. So I'm taking time off my valuable nap time here. Since I'm taking leave between jobs, I tend to take a nap at this time. Just kidding. But anyway, yeah, it's up to you to make this a valuable session. Ask questions, interrupt me if you need to, and yeah, let's have a fruitful discussion here. I will also ask questions in the middle, and yeah, I probably won't move on until I get an answer from a student. There's also a catch in the Q&A session. The catch being the first question must come from a student. The reason I'm putting so much pressure on you guys is I've been there. I've been in the same seat as you guys, although you guys are doing it online. Like especially during undergrads, you kind of tend to be backwards, like, kind of afraid to speak to other people, speak to people from overseas. Kind of need to get rid of that. So going to put so much, some pressure on you guys to kind of get answers, to be more vocal, to be more forward in this session. Great. So with that, let's get started. So I think Anjana, who's coordinating this, I've sent a poll to him. Can you maybe share that with the rest of the team, the students? So there are two questions. Can you answer these? It's going to be anonymous as far as I know. Just need to get a feel for what your preferences are and what you're planning ahead for your future. So I'll just keep sharing this so you can also see, the responses. And yeah, I'm probably going to wait until at least I get 50 answers, or like 33 actually, all of the answers. That's pretty good. Cool. So as you can see, a lot of you are planning to be data scientists. That's great news. I didn't expect that many yeses, to be honest. Okay, so we have like more than 3/4 answered. All right, cool. Can we maybe go to the next one? All right, I was so wrong about you guys. You guys are actually much better than me when I was there. Cool. So yeah, again, didn't expect that many yeses. This is great actually, because one thing is, for example, at least in Australia, when so I'm gonna just close this one. Thanks for everyone who responded. It's pretty useful. At least for me, when I came to Australia, I felt the PhD really helped me to kind of make a statement as a data scientist, because when you do your higher studies, you kind of get an instant recognition, kind of a layer of recognition on top of what you can already do when you're joining the industry or the academia as a data scientist. So it's great if you're planning to do higher studies. I think it will be quite valuable. Cool. So let's kind of dive into it. All right. So this is a little bit about me. So I started my, I'll just go chronologically. Finished my BSc in April 2014, and I started my PhD at the University of Sydney, Australia in January 2015. I published my first book. So as Shahansa said, I published 2 books. So I published my first book by June 2018, so 3 years after. Around in September 2018, I finished my PhD. Right after, I joined QBE as a data scientist. So for those who don't know, QBE is an insurance company in Australia. They have an analytics team. So we're looking at various problems that are in the insurance space. So I was actually there for 3 years. So I resigned on 11th of September. Along with that, I finished my second book as well, which is a great feeling because it's been going on for forever. And I'll be starting as a senior machine learning engineer at Canva by the end of September. So technically, I'm unemployed. So if you guys don't feel like getting advice from an unemployed person, feel free to leave. I'm just kidding. Cool. So that's kind of where I am right now. So it's been an eventful journey. But what I want you to kind of pay attention to is these green and red bars on the timeline. So those kind of represent how I was feeling at each time, like close to each milestone. So I kind of started at a very high note, my PhD. And during my PhD, I mean, I enjoyed it, but not as much as I enjoy working in the industry. So like, wouldn't say like I was a star student there. I published a few papers, not as many as I wanted to. I had like quite a few rejections of papers as well. So wasn't feeling super good about it, but I was able, did enough to graduate, I guess. After I graduated, became a data scientist at QBE. That's when I kind of felt like that's where I want to be, because I really enjoyed working on the applied side rather than theoretical side. Different people will feel different way. I have friends who really enjoy the academia, have friends who enjoy the industry. So it's a kind of, a field you have to get for yourself. So there I was really able to kind of climb up the career ladder quite quickly. I worked on quite a few impactful projects. We had a really great team there who were quite helpful. We had a lot of cross-pollination where we shared information with each other, worked on projects together. It was a really good time. But even then, had times that, I was kind of overloaded with multiple projects. So I was working on 5 different projects at a certain time. I was getting pulled in all different directions. And yeah, at that point, you get too stressed and you have to kind of take work off of you in order to recover. So I had those kind of moments as well. That's what that red bar there represent. And after that, it's been kind of an upward trajectory for me. So I don't know what I have in store at Canva, but hopefully it's something good. So just goes to show you the first kind of lesson, which is not completely relevant to data science, but important nevertheless, is that you will have ups and downs in your life. Everyone goes through that. There's nothing to be discouraged. Just keep pushing forward. So that's the first lesson. Cool. The second part is going to be how a day in my life or as a data scientist it looked. So I start my day. Let me try to get rid of this thing. So I start my day with meditation because I like to go to work with a positive attitude. If you are happy, it kind of sends a certain vibe to other people as well. So when you're happy, you're kind of making other people happy as well. So I really like that. So I start my day with meditation. Then we have things like meetings with stakeholders. Why meetings with stakeholders? Stakeholders are customers. At QB Insurance, what we do is we develop products for other parts of the business, for example, claims officers. Then we have people like underwriters who are kind of creating these policies for insurances. So people like that, there's tens and hundreds of different departments, and for certain different projects, different parts of that business become stakeholders. Why these meetings are important is that you're developing something for a customer, and you have to make sure your hopes for the product or what you think the product should be is in line with what these stakeholders expect. You can't wait until the end and deliver something and make them unhappy. It's going to be bad for you. That's going to be bad for them. So you have to have regular meetings with stakeholders in order to make sure your goals are aligned with each other. Then I typically have brainstorming sessions. These brainstorming sessions include kind of helping me to go outside the box. So I'm usually working on a certain project. I'm working on a certain solution. When doing that, I rarely get time to kind of think outside the box, think about other stuff I can do. So I take time off to kind of think about other use cases we can solve, different technical solutions that are out there for the current problem I'm working on. So you need these kind of sessions to disconnect you from the current reality and think about other options you have at your disposal. Then we have things like sprint planning, a sprint retro. What a sprint is a 2 weeks time box. So we follow the agile methodology. So you probably heard of that, kind of break into 2 weeks sprints, and then you kind of plan for each of those chunks. So that's what we do. We have sprint planning sessions, we have sprint retros. In the planning session, what we do is we think about what we want to deliver by the end of 2 weeks. That might not be much because these projects can go on for 6 months or a year. So it might be a really small part of the project, but it's still important. And then what we do is once we define the goals, we will break them down to subtasks and assign them to different people. And each of those people will need to estimate their efforts, like to show how long it's going to take to deliver on that piece of work. It's a very difficult skill to master. It might sound pretty easy, but it's very difficult because there are a lot of dependencies on other people. For example, a task you are working on, might depend on another person's work. There are unexpected meetings, there are unexpected hurdles you hit in developing a solution. So it can be really hard. Then we have sprint retros, which are kind of retrospectively thinking about what we have done, the good things we did in that sprint, the bad things we did, and create action items to promote the good things and eliminate the bad things. We also have problems like resolving conflicts, like it's very rare that two people agree on the same solution, from the beginning. It's always going to be conflicts and you have to manage them and resolve them. We have technical catch-ups to discuss technical stuff. And then we have things like pilots. Pilots are about once you're close to a delivery, it's kind of like the trial version of your product. So you give them the trial version, you see if they're happy. They're not happy, we take it back. We make the changes they need. And so we create this iterative process until they're happy with the solution. Obviously, you have coding, and then you have things like one-on-ones with your manager. These one-on-ones are about whether you're going in a direction that is strategically aligned with what the company expects, or where the company is expecting to be in, let's say, 3 years or 5 years. It's a really important thing because companies have visions, which are kind of long-term goals, and you need to make sure your goals are helping the company to get there. So these kind of conversations happens with the manager. What I wanted to show here was that coding is a very small part of the data science job. There's so much other stuff that goes on, and that are much more important to make a project successful. So don't just focus on the coding, also focus on the other stuff. I'm not expecting you to remember any of these. Just remember that coding is a very small part. And yeah, it's a lot of factors that actually deliver a successful project. All right. Okay, so yeah, I told you that I will, kind of break it down, what kind of things you might be going into when you're graduating. And if you want to become a data scientist, what kind of problems you'll be working on. It's not going to all have a fairy tale where every one of you are working on amazing problems and solving amazing thing always. There's a wide variety of different tasks in data science, and most of the tasks would fall into one of these categories. So here you can see there's things like process automation, there's business rules, there are low to medium scale machine learning problems, and there are high scale machine learning problems. The proportions don't matter that much as the ranking of each of the components. So the first thing is there's a lot of process automations. What are process automations? Process automations are what it says, automating a process. Businesses have a lot of processes. For example, I'll take examples from the insurance domain because that's my most recent experience. For example, they have Excel files that fly all over the place between different people. And each person would add a column or edit a row and send it off to the next person. So it goes through this labyrinth of people, and then it reaches the manager and they would approve it, and yeah, the process ends there. So like this, there's hundreds, if not thousands of processes for a large company. Some of the work you'll be doing, is automating those processes. To be honest, there's zero machine learning in there. Like a simple dashboard and a database would, do the job. But that's also a part of the process. I'll talk about the importance of this, even though these are not machine learning. I'll talk about why they're important for machine learning problems later. Then you have things like business rules. So this is a little bit more close to machine learning. So here you would have a series of questions you would ask to reach a decision. For example, if you were driving and if you were in a car accident, you would call your insurance company, and the claims officer who's taking your call will ask you a series of questions. Once they ask the series of questions, they would reach a decision. So either, ask you to just create a claim, or, either tow the vehicle. If it is not drivable, they would, send a tow truck and let the tow person drive the vehicle. If not, they would just, tell, okay, drive back and, make a claim. So something like that, there are different decisions involved. So some of these data science problems are about automating this decisioning. So what you would create is something like a decision tree, and then you store the responses in a database, and you're done. And then you have machine learning, like actual machine learning, where it would require a machine learning model. So what the machine learning model does is something a person previously did. There are claims officers or like other business teams at the insurance company who would look at previous historical claims and make certain decisions on them. For example, there are these things called recoveries. For example, let's say you're driving a car and you crash into a fence of another person's house. And then what you would do is, if the person, if the person owning the house is insured with us, what they would do is they would claim, the expenses from the insurer. And what the insurer would do is the insurer would go to the insurer of the car who crashed into the fence and claim the money from them. So that's called a recovery. So these things are not evident at the beginning. So you need to wait a certain time until you actually, make a decision on these claims. So what you do is you go back to the historical claims and make decisions on them. Where does the machine learning fit? So the machine learning is that small sawtooth you see here. What it does is, instead of the person having to look at hundreds and thousands of claims, it would go in, it would use the past historical data that the person made decisions on, it would train on that, and it will make the life easier for the person. So these machine learning models are called decision support systems. That's another misconception that they have, like people have, like, they're all going to replace jobs, kind of put people out of jobs. It does that to a certain extent, though. I wouldn't deny it, but it's not all that. It's usually an enhancer for the person, because machine learning models are never 100% accurate. So if you have a claim with hundreds and thousands of dollars, you can't trust a machine learning model to, take care of that, because it can end up being a really bad experience for the company. So usually there's always a person verifying the results of, a machine learning model. It might not be, looking at every single thing, but at least a random sample of that needs to be verified by an actual person. So that's what the machine learning models typically do. They just sit between the raw data and the person and give the person a much more sensible or realistic list of things to look at instead of everything in the database. And finally, about 1%, you have these high-end tech companies doing high-end machine learning: Facebook, Google, Apple, Netflix, those kind of stuff. So probably all of you, I'd be really happy if all of you go in there, but realistically, you probably you'll see this kind of distribution when you if all of you become data scientists, you'll be working on this kind of a distribution of things. Like not all of you will end up at Google, Apple, and Netflix. So it's important to know what's out there to make sure your expectations of data science is aligned with what's actually out there. So these companies, what they do is the things they do differ in certain ways. First of all, they're dealing with very large amounts of data, and they're also dealing with a lot of models. For example, if you open the Uber Eats app, it kind of triggers hundreds of models to load that landing page. So that's the scale they're working at. So to make sure models work at this scale, because they have hundreds and thousands of users, you also need other things around machine learning, like scalability, security, all of that. Because if you don't have scalability for a machine learning model at Google or Facebook, it's like kind of, you know, putting a piece of bacon in a tank full of piranhas. At the end, all you're going to have is a bunch of angry piranhas because the model's going to crash with that amount of a load. So they have to worry about much more, I guess, much more difficult problems than if you are to work at a bank or an insurance company or retail, where they use much lighter machine learning models. Cool. All right, so I'm going to move on to another section. So data science is actually not just about data science. So there are three key pillars I've identified here, which are contributing to data science. So I need you to kind of type on the chat some of the things you think that are valuable for data science. What kind of other things that might be useful? Okay, so I'm not seeing any responses. I will need responses, as I told you. Okay, we have domain knowledge, we have statistics. Okay. Yeah, domain knowledge is quite important, statistics as well. Yes, programming, data engineering, that's a really good one. Business data cleaning, pre-processing, data migration. Yeah, great. Those are some great answers. Open-minded analysis, BI tools. Yeah, cool. So this is what I have identified. What you all have said goes in somewhere in this pie chart. It might be a subsection of that. So data engineering is a very important part, because if you don't have scalable or efficient ways to extract data from your databases, your models are lost. So you need good data engineers designing, making good database choices, for example, between SQL and NoSQL. And then you have to design the schemas, make sure, you know, you're not kind of exerting too much force every time you're retrieving data. So you need to make sure your schema is in a certain format that it has the least amount of queries that it has to perform in order to get the data for the machine learning model. And then you have things like ETL pipelines, which are extracting, transforming, and loading the data for your machine learning models. So all of that kind of lays the foundation for machine learning models. And then you have the actual data science. So in there, you have the data analysis, model training, statistics, model evaluation, all that. And then you have things like ML engineering. ML engineering is introducing that engineering piece to the model. So your model needs to be wrapped in a sound, I guess, as a software, a reliable software. So that's what the ML engineering component is. It takes care of, it makes sure you have good infrastructure. It makes sure you can serve one customer, and you can also serve hundreds and thousands of customers without crashing the model. Has security, especially in the banking and insurance sector. Security is quite important. Like if you you have so much sensitive information there. And if you end up exposing or someone breaching this information, the fines can be very heavy. Like recently, one of the banks got fined $1 billion, not because someone breached, but because there were human trafficking accounts in like human traffickers were using their bank to transfer money. But nevertheless, the fines can be very very tough if something like that happens. So you need good security around these models. And then you have things like CI/CD and MLOps. What CI/CD does is it allows you to continuously deliver and deploy models, because in machine learning, you never kind of train a model and set it aside and just forget about it, because you need to train the models again and again, because models become stale. Your data can change in the future, and you need to have ways to kind of trigger these kind of changes or detect these kind of changes and make sure you retrain your models when something like that happens. So all of that goes into CI/CD, MLOps kind of domain. So those are the 3 key pillars. Cool. So I'm actually running out of time as well. All right. So this, I'm going to ask you a question. So this is a landing page of the newest company product that I'm going to. So we're going to do the first step of a data science project. That's identifying a business problem. Can you think of any particular, problems you can solve here by looking at this UI? What kind of things can we use machine learning to improve the customer experience here or increase the profits of the company? It might be a little bit of a tougher question, so I'm not going to always wait for an answer, but I'll just give you a 1 minute time if anyone wants to answer. Okay, doesn't look like we have any takers. So I'll just jump right into the answer. So the parts that are highlighted in red. So for example, you can include things like auto suggestions and recommendations, search recommendations to help the user search something quickly. So that's one problem you can solve. And you have sections like this personalized recommendation sections, like for you, where you could, like, for example, if you're looking for a presentation template, based on the past user experience or past user interactions, you recommend them new templates that are created by other designers. So that's another thing you can do. And they have a premium feature. That's how Canva makes money, by converting free users to premium users. And you can create personalized marketing emails by using machine learning so that more users will be converted to premium users every day. So things like this. So that's usually how data science problems come out. Like, just look at a product or you look at a way of doing things, and then you think, hey, can't we just automate this, or can't we just improve this by using machine learning? So that's how you identify a problem. And that's the first step of data science. All right. So here are some of the actual real world machine learning use cases that I've used daily, or like I use regularly in Australia. So in retail, they use machine learning to create personalized offers. So Coles is the biggest supermarket chain in Australia. or one of the biggest. So what they do is based on the, and they have their reward system. So what they do is they create offers dynamically based on your interactions with those rewards, like the ones you activated. If you have activated certain ones, they would give more of those rewards to you. And in banking, what they do is they would predict your next bill, next expenses in the next month. So if you have a month with more expenses coming your way, you could increase your savings, things like that. So banking use machine learning for that. Insurance use machine learning for premium calculations, customer churn. So customer churn is when a customer leaves insurance, that's churning. So what they do is, if they can detect this kind of churning early, what they do is they give them discounts, they give them deals, and try to retain those customers and avoid them leaving. There's also space for improvement in claim allocation, because not all claims officers will be able to process every claim. They have different expertise, they have different workloads. So you can factor this in, create a machine learning model, and assign different claims officers different claims to increase the efficiency of claim processing. In real estate, they use machine learning to predict the market trends. So, if the house prices are increasing, they can predict that. So for things like that, real estate uses machine learning as well. So this is some of the only a few few examples, but there's a wide variety of different use cases that they use machine learning for. Cool. So that brings me to the end of this presentation. So the last thing I wanted to leave you with is, in all of this, the most important thing is at the end is to, be a good human, because the happier you are, the more productive you are. Typically, that's a lesson I've learned. So, and it also kind of helps the people around you to feel happy as well. So that's quite important. Again, the other thing is mental health. Like, like, for example, when you're in uni, or like when you're early in your working years, you need to kind of put your feet down and kind of work a lot, but you need to also be aware if you're getting too much stressed, or kind of your mental health deteriorating. You need to be aware of these kind of things as well. And family and friends, never forget them, because no workplace would replace them, because workplaces, people come and go. It's impossible to create that kind of an environment that you would get from a family or friends within a workplace. Like, you can't replicate that fully. Always have a balance in work and life. Whenever I speak to my friends, I kind of, it's kind of become normal in Sri Lanka. I don't know, that's what I'm seeing, at least. It's sometimes working at 2 a.m. I know 5 a.m. It's not that healthy. So always try to have a work and life, like the balance doesn't have to be 9 to 5. It can be longer, it can be shorter, it can be different times, but always have that separation between work and life. Exercise also promotes, kind of better living standards. It helps you to kind of, create that brain chemicals that helps you to be happy. So exercise should be always a part of life as well. So I know it's completely irrelevant to data science, but this is quite important as well. And on the other hand, if you are actually happy, you will do much better, much more productive work as a data scientist, and also lead a fruitful life. Cool. So I know I went 10 minutes over the time. Do you have any questions?
Yeah, thank you, Thushan, for interesting session, and also looking at from a different point of view. While we are waiting for questions, let me ask you a question regarding you. You definitely talked about a very important aspect of making sure that you are healthy, right? I mean, physically and mentally. In organizations where you have worked, have you seen any work being done, or anything actively done to monitor that through certain machine learning or data science approaches, or is it just you do it personally? Because we are in a situation where the students are all over the country, and we have been teaching for almost 1.5 years. We don't see them. I mean, very rarely we see them, right? If we physically see them, we can see certain changes in them, and maybe we can ask them and try to address them. But now it's like quite remote, right?
Yeah.
That put you in a spot. Or have you seen in the
No,
organizations
like that's
where you have worked with anything being done?
That usually very like to be honest, I haven't really seen machine learning being used. I know like there's a few researchers that are like there to detect depression and anxiety, for example, but they're all in kind of academia. I haven't really seen that used in kind of widely across the country. There might be small institutions that are using that, but for example, in my company, what we do is we do kind of this well-being check where everyone has to give a number between 0 and 10 based on how they're feeling, and they have to kind of explain why they're feeling that way. So that's something we incorporate in most of our meetings. I've found that helpful if you're actually being honest. So yeah, that's something we've done in my past company.
There was this question. I think it's addressed to you. I just posted it to you. Actually, we also started a stream on data science, so this might be relevant for people who are looking from outside. Okay, you can give your take on this because you have a lot of experience.
So nowadays, is offer data science specializations. It's better start our career as such a degree or do a software engineering specialization and go ahead to develop skills. Yeah, it's a really good question. What I would say, you definitely need the software engineering like you need software engineering skills to be a good data scientist, because I've seen data scientists writing very unreadable, unmaintainable code, and it end up being a very large overhead for the person who's taking it next. If you kind of do a deep dive, you just find out that person doesn't have much software engineering experience. So it helps you to write maintainable and readable code. And in the long run, for companies, that really helps. So, and if, I don't know if you've heard this, but like, for example, the director of Tesla, I think, so that's Andrej Karpathy. So he calls machine learning software version 2. It's just a step ahead of software. So you still need the software in that. I've seen like data scientists with very bad software engineering practices. And yeah, the missing part of the puzzle is software engineering. I would recommend that, but if the data science specialization includes that, that's fine. But you have to kind of have a look at the syllabus and decide it for yourself. Did that answer the question? Okay, what skills should I improve to be a data scientist? So the skills, I guess, are in those 3 pillars, I guess. You need to have a all-round understanding of all the things. So you can't just ignore the whole database side and be a good data scientist. In my past experience, I had to design databases sometimes. Well, I mainly did that because I wanted to learn. I could have avoided it, but I still had to design. I had to design schemas, create ETL pipelines and all that. And I think in retrospect, that made me a better data scientist. So I would say if you can focus on all the areas, data engineering, data science, ML ops, or ML engineering, all of that doesn't need to be, it doesn't mean that you equally need to pay attention to all of them, but you need to at least know the basics of ML engineering and ML data engineering in order to be a good data How did you get a PhD? I applied externally. So I just reached out to one of the supervisors here in the University of Sydney. And yeah, just email basically. And the process started from there. But I guess you can go to Shahansa and ask. I know there's like, for example, Gaishan went through the university, if I'm not mistaken. So yeah, there are processes there.
To depend on whether you want to stay in the university system or
Yeah. So you have to return to the university. Cool. What are the latest tech stacks you need to follow in Ninja? I would definitely, so in terms of the tech, I would definitely recommend you following tech blogs of those top tech companies like Airbnb, Netflix, Uber, Google, Facebook. They all have their tech blogs. I'm happy to send some links to I guess Anjana through that email, and he can share those with you. But yeah, I would definitely recommend following them because they use the latest tech, and I've learned a lot from there. If you ask me, like, what are the latest libraries? I mean, we use TensorFlow a lot, we use PyTorch a lot, scikit-learn, but there's too many to name, to be honest. Depending on the actual data science project I'm working on, I might be using different libraries. For example, there are some projects where you need to log a lot of information. In that case, I would use a like a very fully fledged logger, as like one of the libraries. So it really depends on what you're working on. Yeah, again, I mean, to be honest, like I've seen, students who are in the electronics who became data scientists later. So that's not an objection. Like, that's not a barrier for you. It's just that, again, as I said, software engineering is very important, to become a data scientist. So don't ignore that. Learn about the software engineering in any ways you can. Statistics is important because, for example, when you have results from a machine learning model, you sometimes need to see if those results are significant enough, to say that the model did something differently or model did something better. So for that, you have to use statistical tests like t-test or, p-values and all that. So those are all in statistics. Again, you can't ignore that. It is very important. And depending on the company you're going for, like in the interview, there's a good chance that these questions will be asked. Medical related research, which areas will be beneficial to focus on?
Thushan, if you can repeat the question also, that would be good, because
okay.
Others can't see the question.
Yeah, the question is with regard to the medical related research, which areas will be beneficial to focus on as this, as it's widespread, or like there's a lot of options. I mean, again, if you know the basics of data science, there's nothing stopping you from applying that to medical related research. To be honest, I don't think there's anything that different other than the domain knowledge, of course. So you need to consult doctors to understand what you're looking at, because unless you understand the data, you can't do much with the model, because first you have to understand the data and see for yourself if things can be automated using a model. So for that, you need to understand data. So understand the data would be the most difficult thing. I don't really think you'll need to learn anything special about models or machine learning when it comes to medical research. I mean, reading a few papers would probably, be enough for that once you have the foundations. All right. Do data scientists spend more time on data cleaning. Yes, not just data cleaning. To be honest, I spend my most of time, like I would say 80% spent on data and 20% spent on models, because models are much more standardized than data. Data is the problem. Like most of the time, the problem is not being able to understand data. You know, if you need models, there's XGBoost, there's linear regression, there's logistic regression. There'll hardly be any you know, need to go in and change those models. You can just use those models as they are. It's the data that you need to understand first. So data is, I would say 80% time I would spend on data, understanding, cleaning it, exploring it. So there's the other question, what is your opinion on this huge hype towards data science and ML? How long do you think this hype will continue? That's a really good question. I think the hype will still be there. It's just that I think the data science role would change in the future, because what we are seeing right now is because these cloud platforms offer most of these models out of the box. Like you only need to do you know, few clicks to get a machine learning pipeline on a cloud. So you don't really need to do much of custom scripting there to get something up. So what would I think end up happening is this ML engineering aspect, like, you know, making models scalable, making sure they're robust, making sure the models are explainable. Things like this will become more and more important rather than creating models and training them. So I think there will be a shift towards that side of work. Right? You know, for example, right now I'm I guess I'm more focused on modeling, but there will be a shift towards those things because the cloud platforms are kind of taking that part away from us. So can kind of think of this as the, you know, kind of data scientists replace the other jobs and clouds are going to replace us. Well, not replace, but shift. Do you have any advice for an undergrad who has divided thoughts on taking a traditional software engineering job or a data science job? Really depends on what you like. And also keep in mind that you're not entirely stuck with a certain role just because you chose it first. You can always move between jobs. I mean, I know like a colleague of or a batchmate of mine who started as an electronics, like he did an electronics undergrad, then went to accounting, he did a CIMA, he became a chartered accountant, I think, and then he did a PhD in data science, and now he's a data scientist. So, you know, like it doesn't stop you from changing things. So just get a feel for yourself, see which one you like, and then stick to it. Right, so the other one, by the way, do we have time? Keep talking, but
Yeah, we'll have another 5 minutes maybe. Thushan,
okay,
yeah, good,
cool.
good to have a lot of questions, right? So
Yeah, definitely. Can you give idea about ML engineer? Do they use programming and maths for their job? What kind of programming languages do they use? In maths side, do they use stats only? So right now, so again, this is not always the case, but in like my previous company, what we had was data scientists would do all the model related work. So they will get the data, they will understand the data, they would train the models, they will evaluate them. And once they're happy with that model, they hand it over to the ML engineers. ML engineers, what they do is they create these containers. They, like, for example, they use Docker. They would create images and containers that holds the model and create servers, scalable servers around them to access those models. They were working on I think, kind of a more efficient model training platform or something. So you can see all of this doesn't involve any modeling, but they're kind of facilitating model related tasks like model serving and model training. So that's what the that's the definition I'm used to, but I know some companies kind of, for example, the new company I'm going to, Canva, they're called data scientists and machine learning engineers, just machine learning engineers. So it's up to the company really to define those roles. But this is the one I'm familiar with. In terms of what they do, there is some theory. For example, machine learning engineers need to know about distributed computing. Distributed computing comes quite a bit when it comes to training models at scale and serving models at scale. That's done in distributed fashion. So they need to know kind of basics of distributed computing. They need to understand modeling to a certain extent, but not as well as a data scientist. In terms of the tech stack they're still using Python mostly. They use Docker. For model deployment or model serving, they would use things like GUnicorn, which is I think it's a gateway. Then you have Flask to serve models, and then you have things like Traffic, which are load balancers. So they kind of need to know a lot of this stuff. They need to know about security. They need to know about networking, modeling to a certain extent. So yeah, these job definitions, they're not, I wouldn't say like they're well defined. Like it really depends on the company you're going to, what you will end up doing. So the more you know, the better chances you will have in terms of getting these jobs. So next question is MSc in AI, and is there any opportunity to work as a ML engineer? Currently, I'm working as a full stack senior engineer. Yeah, I mean, again, like if you're doing an MSc in AI, like here's the thing about machine learning. So I'm not that big on, like, for example, ML engineering. I haven't done any courses. I haven't, done anything, to be honest. Like I've read a few books. I've learned from those tech blogs that I'm following. I've looked at the TensorFlow blog. So from that, I kind of picked up the concepts. And once you know the concepts, it's not that difficult to kind of follow through and learn by yourself. So as long as you're in some stream, some relevant stream, you can always kind of make those lateral movements between data science and ML engineering. So yeah, I don't think it would stop you from doing this. It's just that, yeah, you might face certain challenges. I can't really be sure of that because I haven't done this myself, but I don't really think this would be a blocker for you, since you have an MSc in AI already. There is definitely an opportunity for you to become an ML engineer.
It would also mean what was covered in the MSc in AI, right? So depending what was covered, right? So should be able to, right?
Sorry, sir, I didn't understand.
No, what I said was it would depend on what is covered with the MSc in AI also, right? So
yeah. So like, yeah, that's a good point, because in Australia, I mean, if I look at 5 different AI courses, they typically tend to be the same. I don't really know how that's in Sri Lanka, but yeah, it would definitely depend on the content of that course. But also keep reading about the stuff, even if it is not in your course, just explore, research, and that will definitely help you down the track. Some person is very good at programming and business side, but not more interested in maths. Can they survive in data science if use jobs? I wouldn't really recommend this. I would say maths is quite an important part. Like you don't need to know calculus or differentiation, to the extent where you prove, I don't know, 1 + 1 = 2 or something, but you still need some maths and some statistics. yeah, I've seen people like becoming data scientists without these backgrounds, but I've also seen the work is not that great. Like I've interviewed like 50 odd people for QB insurance, and yeah, every time they lacked one of the foundations, it's quite evident from the interview. So I wouldn't recommend this. I would recommend kind of laying the foundation, because that's very important. Yeah, even the maths that's relevant to data science, if like you don't need to dive into maths to become a mathematician. It's not what I'm saying, but you need to know the basics, I would say.
Okay, do you have any other questions? Or
I think that's it.
okay,
Yeah.
okay, it's a good time. Nisanta is also still there here. Nisanta, anything you want to add, or Gaishan, anything you want to add to the answers that were given? I mean, that's good, but
let me ask you, Thushan, maybe a concluding remark about data science, and because you have been in the industry for so long, what is your perspective about the industry towards the data science maybe in the next 5 years or 10 years?
I mean, the short answer is I think it'll boom, because even right now, like during the COVID pandemic, like there was so much, like there was a really huge market in Australia for data science jobs. Even like QB Insurance was hiring actively. So, if they're kind of booming in a pandemic situation, I mean, I don't see that really slowing down in the next 5 years or so. But things are becoming more standardized. So there will be less and less kind of, need for like custom interventions during the modeling, but there's still kind of like you need those data scientists there to understand the data, to choose models, to choose features, all that. It is still way out, way off from automating them.
Okay, thank you, Thushan, for your great session. I think everyone enjoyed the whole session. We can see that from the questions, the amount of questions that we got.
Yeah, I think like I scared them quite a lot.
Thushan, you pointed out that it is good to, it's okay to not have a formal education, and it's okay to learn by yourself, right? And in the industry, how, what have you seen on how people would go about in proving that they do have the knowledge when they are a certain job?
So yeah, I should have maybe rephrased, like I wouldn't say like without any formal education. Like I don't know where I would be if I didn't have the bachelor's. I did, because I've seen like people coming just do Coursera courses, or just claiming to be data science. Like I've seen them getting jobs as well, but they don't understand the form. When you ask them like why you picked a certain model, like why did you pick XGBoost instead of logistic regression, like the answers would be things like, oh, I used it in Kaggle. I mean, it's not really a good answer. Kind of see these kind of like gaps in their knowledge whenever like they come without that formal education piece. Doesn't need to be like something as big as a machine, I don't know, BSc maybe, but still it's quite needed. Yeah.
Okay, thank you.
So you need to have a balance. Yeah. Okay. Right. So let's conclude the session, and thank you, Thushan, once again for joining us, and hopefully you will continue to support us going forward.
Yeah.
Okay. Thank you.
All right. Good to see you again. All right.
Thank you, Thushan.
Bye.